Hey guys, Mr. Wilson here. Today we're looking at inscribed angles notes. At the end of this video, you should be able to identify both types of inscribed angles, and you should be able to use inscribed angles to find missing measures within circles. An inscribed angle is an angle formed by two chords whose vertex is on the circle. The measure of the inscribed angle is half of the measure of the intercepted arc. Okay, so let's look at some of those terms here and put them into some reality for us. So in circle O, angle ABC is an inscribed angle. The intercepted arc is arc AC. So ABC, two chords with the vertex on the circle, right? Intercepted arc here, AC, the arc between our sides of our angle. So if the measure of angle B was 21 degrees, what would be the measure of arc AC? Well, the inscribed angle is always half of the arc. So if this is 21, that must mean the arc is 21 times 2, 42 degrees. If the measure of arc AC is 70 degrees, then find the measure of angle B. So let's say that this is 70 now. If this we know is 70, then we say, okay, the inscribed angle is always half of the intercepted arc. So if this is 70, it's 70 divided by 2, 35 degrees. All right, so let's look at some of those examples down here. It says find the measure of each indicated angle and arc. So for the first example, it asks us for angle ADB. Angle ADB here, draw it. Now I like to say, okay, where's my intercepted arc? My intercepted arc's measure is 76. So the inscribed angle is half of that, 76 divided by 2, 38 degrees. Okay, as we look at arc DC, okay, arc DC, they told us that this angle is 45, and we know that this should be double of the inscribed angle. So if this is 45, that must mean that our arc is 90. Okay, again, I just like to make it visual for myself. I draw it out to see what's being included here. Okay, you don't have to, but strategy I found to be helpful. Number 2, it asks us for the measure of angle POQ. Okay, notice here that POQ is a central angle. POQ is our central angle. No numbers here for us with the arc, but the intercepted arc is PQ. As we look at our inscribed angle here, you'll notice that this angle QRP intercepts the same arc PQ. So since this is an inscribed angle in 62, its intercepted arc should be double. So 62 times 2, and that gives us 124 degrees. Okay, the last one here asks us to find the measure of arc CD. Okay, and so what we'll want to find, arc CD is here. We'd really love to find an inscribed angle or an angle of some sort, maybe a central angle, that tells us something. Okay, and so you'll notice that we do have an inscribed angle that goes with arc DC, and that's angle DAC. Right there. So I need to know this angle right here. I need to know angle A here. Okay, so how can I do that? Well, information that I have is that BXC is 85 degrees. You should notice that these are vertical angles. So if this is 85, this must also be 85. Okay. Triangle AXD is still a triangle, so it should add up to 180 degrees. 85 plus 32 gives us 117. 180 minus 117 is 63. Okay, so we find that this angle DAX is 63 degrees. Since we know that this is 63 degrees, and it is an inscribed angle that intercepts arc DC, or arc CD. And we can say 63 times 2, which gives us 126 degrees. On the back side here says find the values of the variables for each. Okay, using that same kind of information here. And so what they give us, some inscribed angles, A, we're trying to find A. You should notice that, hey, we have PQT that intercepts that arc. If PQT is 60, that intercepted arc should be double that, 120. They ask us for B. Do this in green. Okay, B here intercepts this arc. Okay, now they do tell us that TS is 30. And we just found out that A is 120. So 120 plus 30 is 150. So B should be half of 150, which is 75. Number 2 asks us to find X. And it gives us this inscribed angle, not really gives it to us because it tells us 3x plus 25. And we see it intercepts this arc. Again, doesn't give us a value, but it does give us 5x plus 60. Our relationship is we know that the inscribed angle is half of the arc it intercepts. So I can rewrite it and say twice the inscribed angle should equal the arc it intercepts. Okay, so as I look at that, I could also write it as, and I'm just going to do this up top, that the arc, or that 3x plus 25 is half of the arc it intercepts. Either way, it's the same relationship. Okay, so now as I solve it, I get 6x plus 50 equals 5x plus 60. Subtract 50 from both sides, subtract 5x from both sides. I get x equals 10. Okay. Okay. Other thing we need to know is that the measure of an angle formed by a tangent line in a chord is half the measure of the intercepted arc. Okay, so for angle CBA, which has its vertex on the circle, right? Point B is on the circle here, makes it a tangent line, BC. The intercepted arc is arc AB. Okay, and therefore CBA is half of that intercepted arc. Okay, it's almost like an inscribed angle here. And so we can find the angle CBA is 74, half of 148. Okay, so let's look at a couple examples here. They're asking us to find angle X. You'll notice that we have a chord here that splits our circle. So since this arc is 220, we can find that the arc on the other side should be the rest of our circle, which would be 140, right? And so the value of X should be half of 140, which is 70. All right. Number 2, we're given some values here. This is 54. So since it's an inscribed angle and it intercepts this arc should be half or double 54, 108. Okay, as I'm looking at my inside angles, I should see that this is an isosceles triangle. That's what they told us. And so these two base angles should be the same. So 180 minus 54 gives us 126 divided by 2. Each of those base angles is 63 degrees. So y is 63. All right, and that helps us out. This should be 126, and this should be 126, right? Because that's where our intercepted angles, our intercepted arcs are, okay? Okay, and that all adds up to 360, so we should feel pretty good about our answers there. Okay, so now trying to find X. X is the inscribed angle here with a tangent line. The arc is here, so 126 divided by 2 gives us 63. We've already found Y to be 63. Z intercepts the arc 108. 108 divided by 2 gives us 54. All right, number 3. It says to find the measure of arc BC and angle B. So as we look at that, I'm going to set up my information this way. They give me this angle, 51. It's an inscribed angle. So I know that this entire arc should be 102. Okay, so since this is 72, that must mean EA is 30. I'll write that there. Okay, EC is also a diameter. Okay, it's a diameter, and so I know that EBC is a semicircle. It should add up to 180 degrees, right? Because BC is what they're asking us for, right? So we call it X. So 30 plus 72 plus X should equal 180 degrees. Okay, that's 102 plus X equals 180. And that must mean that X is 78. 78. So we found out that this arc BC is 78 degrees. Okay, now we're trying to find angle B. And as we look at angle B, we're going to look at an inscribed angle again. Notice B is an inscribed angle. Let me erase some of this stuff as we go into the next problem. Okay, this is still 30. Okay, so now as we look at our inscribed angles then, inscribed goes here to here. Okay, now, we already see that this goes almost to the diameter, and if it were the diameter, then it would be inscribed at a diameter which would be 90 degrees. But here, we add that 30 to it, so it inscribes actually 180 here plus the 30, so 210. So angle B should be half of 210. Okay, so as we look at that, we say 210 divided by 2, 105. Okay, so that's chords. And, yeah, not chords, sorry, inscribed angles, sorry. So that's inscribed angles, and I'll see you.